Alright, today's topic is solving polynomial equations. And I just want to give you a reminder right off the bat that solving equations means to get the x by itself. So what we're going to do is we're going to have an equal sign. We're going to have two sides of the equation. And on one side of the equation we're going to get a variable, and the other side we're going to get a numerical answer. So solving equations, get the x by itself usually. In this case we're going to have polynomials. Okay? Well, let's go back and look at the old method. The old method we had, in an example like this, w squared minus 25 equals 0, what we would do is we would actually isolate the w. So I'm going to add 25 to both sides. And just to remind you that the equal sign is the divider line. Okay? The reason we add is because we're getting rid of subtraction, and whatever we do to one side we must do to the other side. Okay? So that leaves me with w squared equals positive 25. Now, we must get rid of the square, and what we said before is that we take the square root. But when we take the square root, we got to know that there's two answers. Okay? So square root, it's a plus or minus the square root of 25. So we're going to get w equals 5 or negative 5. Okay? This is solving algebraically by moving things from one side to the other. Okay? So we'll get the answers of 5 and negative 5. Okay? Well, we can check those answers, and I've already written the check out here, and prove to ourselves that it does work. And the way you check yourself is you plug in the answers to see if you get a true statement. So when I plug in 5, I get 5 squared minus 25. And I'm testing to see if that's equal to 0. 5 squared is 25, and 25 minus 25 does equal 0. So of course that makes me happy. Same thing for negative 5. When you square a negative, you also get a positive. So we get a positive 25. When we subtract 25, we get 0. So check yourself after you get your answers. Anytime you're solving equations, you get an answer, plug it back in to see if that answer works. Okay? Well, now let's talk about another method for solving these. We're going to solve these by using factoring. Okay? So here's the steps for solving polynomial equations the new way. The first step is to factor. This could be your GCF, this could be your difference of squares, this could be your MA method. The next step is to set each factor equal to 0. When you factor, you're dividing it up into multiples, things that are multiplied together. So you're going to set each of those factors, those parts, equal to 0, and you're going to solve. Okay? Let's go back to the example that we just worked out. We know the answer is 5 and negative 5, but let's figure it out another way. Let's use the new method. Okay? First of all, is there GCF? The answer is no. There's no GCF. Okay, so I go down my flow chart. There's two terms. Okay, there is a difference, and each of these are perfect squares. So what I have here is I have a difference of squares. All right, so I'm going to write my skeleton. I'm going to get w plus 5, and I'm going to get w minus 5. Now don't forget that it is still equal to 0. All right, if you're having trouble with this, you need to come see me as soon as possible, because we have mastered factoring by now. So hopefully you got this and you understand this. So step 1 says to factor. We have factored it into its parts. We're good to go. Step 2 says set each of these parts equal to 0. So I'm going to set this first part equal to 0, and then I'm going to set this second part equal to 0. And what I've just created is two little mini equations. And these mini equations are pretty easy to solve. Okay, so the first one, we're going to solve for w, which we got to get rid of the 5, so we're going to subtract 5. Whatever you do to one side, you must do to the other. And I'm going to get w equals negative 5. That was one of the answers that we've got before. On this one, w minus 5 equals 0. I need to add 5. Whatever you do to one side, you must do to the other. W is going to equal positive 5. So we still get the 5 and the negative 5. We just got it in a new way. We got it the factoring way. All right? Let's use these skills and apply it to a different problem here. Change colors. All right, what we have here is we have 2c plus 16c equals 0. Okay. First thing we always check for is the GCF. There is a GCF between these two. They both have a number 2 that can go into them, and they both have c's. So the GCF is 2c in this case. Okay. Well, 2c squared divided by 2c just leaves me with a c, and 16c divided by 2c just leaves me with an 8. Now I need to go through my flow chart again to see if this breaks down even more, but it doesn't. Okay, I'm just going to tell you it doesn't. So now step 1 is complete. It is factored. We factored this by GCF. Okay. Now step 2 says break each part into 2 mini equations and set them equal to 0. So this will be 2c equal to 0, and this will be c plus 8 equal to 0. Solve each equation. This 2 is attached by multiplication, so to get rid of multiplication you divide. 0 divided by 2 is just 0. Okay. On this one, c plus 8 equals 0, I'm going to subtract 8, and I get c equals negative 8. I got my 2 answers here, ready to go. Okay. Now getting your answers is half the battle. Knowing that you have the answer correct would be very beneficial to you. And how do you know if you got them correct? You plug them in. I've already worked these out here for you. C equals 0, c equals negative 8 was the 2 answers I got. Plug them in. 0 squared and 0 here. Everywhere you see a c, you're going to replace it with a 0. 0 squared is 0. 16 times 0 is 0. 2 times 0 is 0. 0 plus 0, 0. 0 equals 0. I'm happy. Negative 8, a little bit more work here. Negative 8 squared is 64, positive. Okay. Negative 8 times 16 is negative 128. 2 times 64 is 128. 128 plus negative 128 is 0. So both of these work out to be a true statement. That one is a true statement as well. Okay? Good work. Okay, let's keep track. All right, the next problem we have is t squared minus 8t minus 33 equals 0. Okay, first thing we ask is there a GCF? There's not a GCF. Okay, so we go down our flow chart. How many terms do we have? We have 3 terms. Okay, so 3 terms means we test, do we have an a value of 1? And we do. So we're going to work this out using the MA method. Okay, remember the c value goes on the top and the b value goes on the bottom. And this is the MA method. Okay, M is for multiply, A is for addition. Okay, so we've got to multiply to get a negative, which means one's got to be positive, one's got to be negative. And we get out a negative when we add, which means the bigger number must be the negative. All right, do some computations of different multiples of 33. Really, 33 only breaks up into 3 and 11. So 11 must go here, and 3 must go here, and we're good to go. 3 times negative 11, negative 33. 3 plus negative 11, negative 8. Good. So this breaks up into the factors. X plus 3, and, or excuse me, it should be t plus 3, and t minus 11. And we are solving for t in this case. All right, next part is this: set each factor equal to 0. Minus 11 equals 0. And then you solve each mini equation. So I'm going to subtract 3 here. I'm going to get t equals negative 3. That's one of my answers. I'm going to add 11 here. And I'm going to get t equals 11. 2 answers. Negative 3 and 11. Okay. Of course, if you want to check your work, you plug them in. Already done this for us here. I did t equals 11 first. That's okay. Let's plug it in and get 11 squared minus 8 times 11 minus 33. Well, 11 squared becomes 121. 8 times 11 is 88. And remember, when we're adding or subtracting, we work from left to right. So I get 121 minus 88, 33. And 33 minus 33 is 0. Negative 3, you square it, you get 9. Negative 8 times negative 3 is 24. Work left to right here because it's addition and subtraction together. 9 plus 24 is 33, and 33 minus 33 is 0. So you see that both 11 and negative 3 work perfectly. They are the solutions of the equation. All right, now this one's kind of a doozy. It doesn't look that bad, but the answers we get are, they're fractions, okay? First thing we need to check for is GCF, and there is a GCF. Both of them have x. Both of them have x to the 4th. So I'm going to pull out an x to the 4th. All right. When I pull out an x to the 4th, I am left with 4x squared minus 1. And that's going to equal 0. So this part right here is my GCF. Okay. Now on the factoring flowchart at the bottom it says repeat if necessary. You need to repeat and see if the parts will break down. X to the fourth is not going to break down anymore. But this guy right here does. This is a difference of squares. Okay. Alright, so this guy breaks up into 2x plus 1 and 2x minus 1. Okay. If you need help with difference of squares, please come see me. Okay. Now, we've got this thing completely factored. What we need to do now is to set each of these parts equal to 0. So I get x to the fourth equals 0, 2x plus 1 equals 0, and 2x minus 1 equal to 0. Alright, this one, x to the fourth power means that what raised to the fourth power is going to give me 0? Well, x has got to be 0 in this case. Because 0 to any power is going to give you an output of 0. The second one, it's a two-step equation. What's closest to the x is the 2, so we undo the 2 last. So I'm going to subtract 1 first. Whatever you do to one side, you must do to the other. I get 2x equals negative 1. Then I divide by 2, and I get x is equal to negative 1/2. Okay, not a great answer, but it's, at least it's 1/2. It's negative 1/2 in this case. All right, same process over here. I'm going to add 1. Whenever I do to one side, I must do to the other. I get 2x equals 1. Divide by 2. I get x equals 1/2. Okay, so I got 3 answers in this case. I get 0, negative 1/2, positive 1/2. Okay, this one's not a quadratic because it's raised to the 6th power, but we still get nice answers because we factored it out. Cool. All right, checking our work here. 3 possible answers. The easiest one to check is 0. Plug in 0, you get 4 times 0 to the 6th power minus 0 to the 4th power. 0 to any power is 0, so I get 4 times 0, and that's 0. Subtract 0, you get 0. So, it makes me happy. Now these guys over here, what I did was I changed 1/2 to 0.5 and I put these in my calculator. So when I did 0.5 to the 6th power, I got 0.015625. Okay? When I did 0.5 to the 4th power, I got 0.0625. Then I did 4 times this decimal here, and I got 0.625 minus 0.0625, which gives me 0. And when you do the work over here, it's exactly the same because when you square a negative 1/2, it's the same thing as squaring a positive 1/2. We're not squaring in this case, we're taking it to the 6th power, which if you take an even power, then it's going to always come out to be positive. So make sure you check your work and make sure it matches mine. Okay? Last example. Last example, we have 3m squared minus 15m plus 12 equals 0. Alright, first thing to do is to check for GCF. We do have a GCF. It is 3, and only 3. So get 3m squared minus, 5. That's a 5. M plus 4. Okay, so this guy's the GCF. Now, we look and see if we can factor the rest of this. If you go through your flowchart, you're going to see that this can be factored by the MA method. So I'm going to do the MA method here. Multiply, give me a 4. Add to give me a 5. That's got to be a 4 and a 1. Okay, so this breaks up into m plus 4, m plus 1. Don't forget the 3 that was in the front, so we're good to go. So this guy breaks up into 3 times these 2 multiples here. Now, it says to set each of these factors equal to 0. Well, if we set the first one equal to 0, we get a false statement. So we're just going to throw that one out. Okay? We're going to set the second one equal to 0. Subtract 4. Shouldn't write that. Cancel these. M is going to equal negative 4. Set this one equal to 0. M plus 1 equals 0. Subtract 1. Whatever you do to one side, you do to the other. M equals negative 1. 2 perfectly good answers. Okay, coming from this quadratic. Here's a hint. The max number of answers that you should get, solutions, should match the degree of the polynomial. So we have a degree of 2, so the highest we can have is 2. And here's the last check. You plug these in and they work.